Welcome to Space, Cosmic Explorers. Have you ever gazed up at the night sky and wondered, are we alone? Well, buckle up, because today we're diving into 10 mind-bending signals from the depths of space that might just change everything you thought you knew about our universe. Imagine this. You're an astronomer, sipping your coffee late one night, when suddenly your equipment picks up a signal so bizarre, so utterly alien, that it makes you question everything you've ever learned. That's exactly what happened with our first mysterious message from the cosmos. Back in 1967, Jocelyn Bell Burnell, a graduate student at the time, detected a series of rapid pulses coming from deep space. These pulses were so precise, so regular, that for a moment, Bell and her colleagues wondered if they'd stumbled upon a message from an alien civilization. They playfully dubbed the signal LGM-1, Little Green Men. But don't get too excited just yet. As it turns out, Bell had discovered something equally fascinating: pulsars. These rapidly rotating neutron stars emit beams of electromagnetic radiation that sweep across Earth like cosmic lighthouses. While not alien in origin, pulsars have revolutionized our understanding of stellar evolution and have even been used to test Einstein's theory of general relativity. But our journey into the weird and wonderful world of space signals is just beginning. Let's fast forward to August 1977, when the Big Ear radio telescope at Ohio State University picked up a signal so strong and unusual that astronomer Jerry Amon famously scribbled "wow" next to the printout. This 72-second burst of radio waves, known as the wow signal, came from the direction of the constellation Sagittarius and bore characteristics that made it stand out from typical astronomical phenomena. It was narrow band, just as we'd expect from an artificial source, and its frequency was close to the 21-centimeter line, a frequency many scientists believe could be significant for interstellar communication. The WOW signal has never been detected again, despite numerous attempts. But it continues to intrigue astronomers and fuel debates about its origin. Was it a fleeting message from an alien civilization, a natural phenomenon we don't yet understand, or perhaps a human-made signal that bounced off space debris? The mystery endures, reminding us that the universe still holds secrets we've yet to unravel. Now, let's jump to 2007, when astronomers detected something truly perplexing: fast radio bursts, or FRBs. These incredibly bright, millisecond-long radio pulses pack as much energy as the sun produces in a day. But here's the kicker: they come from billions of light years away, far beyond our galaxy. The first FRB was discovered by accident when astronomer Duncan Lorimer was looking through archival data. Since then, hundreds have been detected, some even repeating. But what could possibly create such powerful, brief bursts of energy? Theories range from the collision of neutron stars to the jets of energy released by supermassive black holes. Some have even suggested they could be related to advanced alien technology, though this remains highly speculative. While natural explanations are favored by most astronomers, FRBs remain one of the most tantalizing mysteries in modern astronomy, pushing the boundaries of our understanding of the cosmos. Speaking of pushing boundaries, let's talk about a signal that made waves in 2015, Tabby's star. Named after astronomer Tabitha Boyajian, this star exhibits bizarre, irregular dips in brightness that defy easy explanation. Some of these dips reduce the star's light output by up to 22%, far more than a planet could cause by transiting in front of it. The internet exploded with theories, including the speculative idea that we might be seeing evidence of an alien megastructure, perhaps a Dyson sphere being built around the star to harness its energy. But before we get carried away, more mundane explanations have been proposed and are considered more likely by astronomers. A leading theory suggests that a cloud of dust and debris, possibly from a destroyed planet, is orbiting the star in an irregular pattern. While less exciting than alien engineers, this scenario is still fascinating, potentially giving us insight into the complex processes that can occur in other solar systems. Now, let's dive into the murky waters of controversy with our next signal: a narrow-band emission detected by the Breakthrough Listen project in 2019. This signal appeared to be coming from the direction of our nearest stellar neighbor, Proxima Centauri. What made this signal particularly intriguing was that it drifted in frequency in a way consistent with a transmitter on a rotating planet. Excitement rippled through the scientific community. Could this be the evidence of extraterrestrial intelligence we've been waiting for? But as Carl Sagan famously said, extraordinary claims require extraordinary evidence. Further analysis revealed a far more mundane explanation. The signal was likely interference from human-made technology here on Earth. It's a sobering reminder of how careful we need to be when interpreting potential alien signals and how much radio noise we ourselves produce. But not all signals are false alarms. In 2020, astronomers detected something truly bizarre, a fast radio burst coming from within our own galaxy. FRB 200,430A was traced to a magnetar in the Milky Way, a type of neutron star with an incredibly powerful magnetic field. This discovery was a game changer, providing strong evidence that at least some FRBs are produced by magnetars. It's a perfect example of how studying strange signals can lead to breakthroughs in our understanding of the universe. Now, let's talk about a signal that's been puzzling astronomers for decades: ultra-high-energy cosmic rays. Detected in 1991, these weren't radio signals, but single atomic particles, usually protons, traveling at such incredible speeds that they challenged our understanding of physics. One such particle, nicknamed the "Oh my God" particle, had the kinetic energy comparable to that of a baseball traveling at 60 miles per hour, all packed into a single subatomic particle. But here's the mind-bending part. According to our current understanding of physics, it's extremely difficult to explain how particles can attain such enormous energies. So where did it come from? What cosmic accelerator could have given it such an enormous kick? Theories range from supermassive black holes to gamma-ray bursts, but the truth is, we're still not sure. These ultra-high-energy cosmic rays serve as a humbling reminder that there are still fundamental aspects of our universe that we don't fully understand. Let's shift gears and talk about a different kind of signal: gravitational waves. First predicted by Einstein's theory of general relativity, these ripples in the fabric of space-time were finally detected in 2015 by the LIGO Observatory. The signal, named GW 15914, was produced by the collision of two black holes over 1 billion light-years away. This discovery opened up an entirely new field of astronomy. We can now listen to the universe in a way we never could before, detecting events that don't produce light or radio waves. Since that first detection, we've heard the symphony of colliding neutron stars, the death spiral of black holes, and even hints of more exotic events. Each of these gravitational wave signals tells us a story about the most violent and energetic events in the cosmos, allowing us to test the limits of our physical theories and peer into parts of the universe that were previously invisible to us. Now, let's talk about a signal that's not from deep space, but is equally mysterious: the Hessdalen lights. These unexplained lights have been observed in the Hessdalen Valley in Norway since the 1940s. They appear as bright, floating orbs that can last for hours, defying easy explanation. While not a traditional space signal, the Hessdalen lights have intrigued scientists because of their potential connection to atmospheric plasma phenomena, the same kind of processes that might occur on other planets. Some researchers have even suggested that studying these lights could help us understand potential atmospheric phenomena on other worlds. It's a fascinating example of how exploring mysteries here on Earth can help us in our search for understanding of atmospheric processes elsewhere in the universe. Last but certainly not least, let's discuss the Oumuamua interstellar object. Discovered in 2017, Oumuamua was the first known interstellar object to pass through our solar system. Its unusual acceleration as it left our solar system led to various hypotheses about its nature and origin. While some scientists, including Harvard's Avi Loeb, proposed the controversial hypothesis that it might be an alien light sail, most astronomers favor natural explanations for Oumuamua's behavior, such as outgassing of frozen gases. Regardless of its exact nature, Oumuamua's passage through our solar system was undoubtedly significant, a message from another star system carried by a piece of rock and ice. It reminds us that the universe is vast and full of wonders, and that sometimes the most intriguing signals aren't electromagnetic waves, but physical objects that carry information about distant parts of our galaxy. As we wrap up our cosmic journey, let's take a moment to reflect on what these 10 strange signals tell us about our place in the universe. Each of these signals, whether confirmed or still mysterious, has pushed the boundaries of our knowledge and sparked our imagination. They remind us that the universe is far stranger and more wonderful than we often give it credit for. From pulsars to fast radio bursts, from gravitational waves to interstellar visitors, we're constantly being surprised by what we find when we look up at the sky. But perhaps more importantly, these signals remind us of the power of human curiosity and ingenuity. Each of these discoveries was made possible by scientists and engineers who dared to ask big questions and build instruments capable of detecting the faintest whispers from the cosmos. As we continue to listen to the universe, who knows what we might hear next? Perhaps the next signal will be the one that finally answers that age-old question, are we alone? Or maybe it will reveal something about the nature of reality that we haven't even thought to ask yet. So the next time you look up at the night sky, remember that it's not just a static backdrop of twinkling lights. It's a dynamic, ever-changing tapestry of signals and messages, each with a story to tell. And we, with our radio telescopes and gravitational wave detectors, our space probes and our curious minds, are learning to read those stories. What signal will we detect next? What new mystery will capture our imagination? The universe is talking to us. All we have to do is listen. Thank you for joining us on this journey through 10 of the strangest signals from deep space. If you enjoyed this video, don't forget to like, comment, and subscribe to Space for more cosmic adventures. Until next time, keep looking up, keep wondering, and keep exploring. The universe is waiting for you.